Hi friends, after this session you will have a lot of clarity on basic trigonometric ratios and height and distance fundamentals. We start with ABC. ABC is a right angle triangle which is right angled at B. Suppose we call ACB as alpha. Please remember, angle opposite alpha is perpendicular. The side opposite alpha is the perpendicular. Hypotenuse is always fixed. In a right angle triangle, hypotenuse is always fixed. The problem is between base and perpendicular. So opposite side is perpendicular. If we say that angle ACB is alpha, then AB is the perpendicular, BC is the base. On the other hand, if we say that this angle is alpha, then this side becomes the perpendicular and this side becomes the base. This is the basic thing that you must always remember. Now we go to the basic angles in trigonometry. We have sine, cos and tan. Sine theta is perpendicular by hypotenuse. To remember, pyar hua. All of us fall in love sometime or the other. So pyar hua. Cos theta is based by hypotenuse. Bekar hua. When someone falls in love, he is usually for some time he becomes bekar. So bekar hua. And then tan theta is perpendicular by base. Pyar bekar. That means after falling in love, you become a bekar aadmi. So I am sure there is a lot of controversy regarding this, but for your trigonometry purpose, we'll remember sin theta P by H pyar hua, cos theta B by H bekar hua, tan theta P by B pyar bekar, and we'll put it in practice in this first diagram where angle ACB is alpha. So for the purpose of this one, sin theta is AB by AC, perpendicular by hypotenuse. AB by AC is sin theta. Cos theta is base by hypotenuse. Base in this diagram is BC, so it is BC by AC. And tan theta is perpendicular by base, which here is AB by BC. So AB by BC. The next table we are going to learn the values of sine, cos and tan for given angles. So the standard angles in trigonometry are 0, 30 degree, 45 degree, 60 degree and 90 degree. For sine theta, you just write 0, 1, 2, 3, 4. In the table for sine theta, you write 0, 1, 2, 3, 4, divide by 4 and square root. So sine theta is 0, sine 0 is 0, sine 30 is half, sine 45 is 1 by root 2, sine 60 is root 3 by 2 and sine 90 is 1. For cos, it is just the reverse. So you write 4, 3, 2, 1, 0, divide by 4 and square root. So cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is half and cos 90 is 0. And for tan theta, we simply do sine by cos, sine theta by cos theta. So it is 0, 1 by root 3, 1, root 3 and undefined. Why undefined? Because cos 90 is 0. So in the denominator if you have 0, then tan 90 becomes undefined. Now let us go to basics of height and distance, where a lot of people have some conceptual issues. Let us say AB is a tower, A is the top of the tower, B is the bottom of the tower, and CD is a man, C is the head of the man and D is the foot of the man. So we draw the horizontal line from A, that is AY. We draw the horizontal from C, that is CE. Now if you look at the figure, we have angle YAC, and we have angle YAD equal to angle ADB because they are alternate angles. AY parallel to BD, AD cuts them, so angle YAD equal to angle ADB. Similarly, angle CBD equal to angle BCE. Again, they are alternate angles. Now, how do we see which is the angle of elevation and which is the angle of depression? Well, when we are looking at any angle, we have to stand at the vertex of that angle. For example, if we are standing at A and we have to take one horizontal line. So at A we take this line and let's say we take AD. So we stand at the vertex. Now since we are standing at the vertex and we are looking down, so this is the angle of depression. We look at this line because we don't look at the horizon. We look at the other line. From A we are looking down, so it's the angle of depression. But angle of depression will not be BAD. Please remember, angle of depression will not be BAD. It will always be the angle which AD makes with the horizon. So we have angle of depression from A to the man's foot is angle YAD. Similarly, if we look at angle BDA, so the vertex is D, that means we are standing at D, we are looking up at A. We don't look at D because that's the horizontal. So we look at the other line which is DA. So we have to look up, so that's the angle of elevation. Now which is the angle of elevation? It will be the angle which DA makes with the horizontal DD. So angle BDA is the angle of elevation. So let's ask a few questions. Angle of elevation of the top of the tower A, angle of elevation of the top of the tower A from the man's foot D, from the man's foot D. That means I am standing at D, I am looking towards A, so it's the angle of elevation. Angle of elevation is what DA makes with the horizon BD, so angle of elevation is BDA. Again, angle of depression of the man's foot, angle of depression of the man's foot from the top of the tower A. So our vantage point is A. From A to the man's foot is AD. As we were saying, angle of depression of the man's foot from the top of the tower A. So if I stand here and look down, that is the angle of depression, and the angle of depression will be YAD. Next, let us look at angle of elevation of the man's head. Angle of elevation of the man's head which is at C from the base of the tower, that is at B. So if you look at the figure, we are standing at B. From B means we are standing at B and we are looking up. So this is the angle of elevation, and the angle of elevation is the angle which BC makes again with the horizontal BD. So beta is the angle of elevation of the man's head from the base of the tower. The next one, angle of depression of the base of the tower B from the man's head. Angle of depression of the base of the tower B from the man's head. So from the man's head, so we stand here. If we stand here, we are looking down. So this is the angle of depression. But angle of depression will be with respect to horizon. So the angle of depression will be angle ECB. Please remember, angle of depression from C to B, angle ECB, equal to angle of elevation from B to C, that is angle CBD. But we have to be careful that angle of depression will always be like this, above the horizontal. Angle of depression will be below the horizontal, like this. Don't take it any other way. Now to just ask one more question, angle of depression of the man's head. We have angle of depression of the man's head from the top of the tower. Angle of depression of the man's head from the top of the tower. So let's look at the figure again. We haven't drawn it here, but angle of depression from the top of the tower. So from A to C, man's head is at C. So if we imagine a line YAC, because we are looking from the top of the tower to the head of the man. We are looking from top to bottom, so it is the angle of depression. It is always with respect to horizon, so it will be angle YAC. YAC is the angle of depression of the man's head from the top of the tower. Similarly, if we can imagine another angle ECA, angle ECA is the angle of elevation of the top of the tower from the man's head. Angle ECA is the angle of elevation of the top of the tower from the man's head. I hope after this you will have no issues confusing sine, cos and tan, or the values of sine, cos and tan, or finding out the angle of elevation and depression. Thanks. Cheers. Best of luck.